welcome to the next presentation in track number 3. Good to have you back. We will now hear about how we can assist the elderly using data science, a topic that's becoming more and more relevant as our societies grow older. I'm sure we will hear about the challenges and opportunities attached to this social demographic group that none of you represents, of course, yet. But of course, we all want to live well and healthily long and ever after. And that's why Sonja and Cédric will enlighten us with their talk today. They're both from Zürich, and let's give them a warm welcome. Thank you very much.
Okay, so hi everyone, and a warm welcome to our talk. We are from Zürich, and we strongly believe that we should use AI for good. That's why today we're going to talk about a project in this area. It's about supporting elderly people with a machine learning-based application. Yeah, as we already heard, we're data scientists from Zürich, and the project is a collaboration with EWB. EWB is an energy provider of Bern, and we supported them in developing this application we're going to show you today. So what is the project about? It is about the following challenge. Elderly people would like to lead an independent life and live at home or live in their home of choice for as long as possible. However, you maybe as their child or their grandchild might not be so happy about this because you are very much concerned about their safety. So imagine that maybe your parent or your grandparent is at home alone and something happens. So maybe this person falls down and gets injured and is not able to get any help on their own. And this might take maybe a very long time until somebody realizes that something is actually wrong. So yeah, you might not be so happy about them living alone at home, and the project is about bridging this gap. So what's the vision? The vision of CIMA, CIMA is the name of the project, or the product is to satisfy the needs of those both sides. So to enable an independent as well as safe life at home for elderly people. So, and this is done by the means of an additional safety net at home, so an ambient assisted living system which works in a passive and invisible way, such that elderly people don't need to deal with technical details. And for those of you wondering now how such a system can be built, the idea is to use power consumption data measured by smart meters. You can see an example here on the right-hand side. This is power consumption data measured in 15-minute step and at the timeline. And yeah, so the idea is to detect patterns in the power consumption data in the daily behavior of people at home. So whenever somebody makes coffee in the morning, prepares lunch, or, for example, watches TV in the evening, this results in a peak in the power consumption. And when this happens regularly every day, this results in a regular pattern in the power consumption. And the idea is to detect these patterns using a machine learning approach. And when then these patterns are found, you can use them afterwards to so when a pattern then is at some point not met on some day, an automatic alarm will be sent out to either you as a relative or to an emergency center, such that somebody is then able to really manually check if everything is all right. Okay, so this is the idea of the application, and now we will go a little bit more detail into the application and show you how we operationalize this solution in the cloud. And I will hand over to you, Cédric.
Thank you very much, Sonja. Here we see one view of the CIMA application. Now we try to formalize this idea of patterns. So we see the red bars. Those represent rules. And rules are designed to detect certain behavior of the people living in the household. And rule consists of a time window, a fixed time window, and threshold for the power consumption. So here, this person might cook dinner in the evening and watch some TV afterwards, which then leads in this elevated power consumption. But here we see that at this day, this power consumption does not spike, and therefore we would trigger an automatic alarm. But since the behavior is not static of the people, the system is designed so that the rules can be adapted to the behavior changes. Now we're going to look at how we implemented this system on Azure in a cloud-native architecture. So we have this database where all the data is stored. The power consumption is stored in this database, but also the rules. And we have two different paths for two different households. So if we have a newly subscribed household where no pre-existing rules are given, then we pre-process the data accordingly and write it into a data file. If the household is subscribed for a longer period of time and already has some rules in place, we have a different data pre-processing so that the rules that are already in place will be optimized. In both cases, the data is written into this data file, which then triggers another function, which includes this machine learning model that Sonja mentioned before. Here, the rules get optimized or get newly generated and then stored back into the database. But this is only one piece of the puzzle that builds the SEMA system, and we are going to look at the entire architecture right now. So we have seen this database at the center where all the data is stored, and we have seen how the rule generation sub-architecture works. But then the remaining system, how does that work? We fetch the power consumption, as Sonja mentioned already, every 15 minutes from this external smart control API, store it back into the database, and also queue this alarm generation. This alarm generation fetches the data from database, the power consumption data, and the relevant rules for this power consumption data. It checks whether the rule is violated or not, and in case of a rule violation, an emergency contact is notified. This whole system can be administered via this web application from different users, and then they can control the different aspects of the system. That was the SEMA project in a nutshell. Thank you very much for your attention. If you do have any further questions, please don't hesitate to come at our booth and ask them. We'll be there and happy to answer all your questions. If you're interested in doing a similar project or working on something different but involving data and machine learning, we're currently recruiting for new data scientists. So also if you have some interest there, please don't hesitate to contact us.
Thank you.
If you do have a different challenge that we could help you with, okay, please don't hesitate to talk to Philip Moore, our head of data and AI. Thank you very much.
All right. Thank you, Cédric. Thank you, Sonja.